1985 BC10. We have this series here, crazy series that converges on the interval from -1 to +1 and is equal to f of x. And we're trying to find the derivative of that. Now, in the early days, what I would do is I would actually write out a few terms of this. Let n equals 1, and you can see that what you'll get there is not too bad. You get 1 plus 1, so it'll be an even power term, and it will be x to the first power over 1, so it would just be x. And so f of x would be equal to x. When x is equal to 2 now, you're going to get an odd power term, so it would be negative, and then you would get 4 minus 1, which is 3, so you'd have x to the third power all over 3. And then from that, for when x is equal to 3, you're now going to get a positive and even powered term, so it will be positive, and x is equal to 3, you're going to get x to the fifth over 5, etc. I think we can see where that's going. So in the early days I would do that out, and then we can take the derivative of that, and we would have 1 minus 3x squared over 3 plus 5x to the fourth over 5 minus 7x to the sixth over 7, and you can see here that those coefficients, or numerator and denominator, will cancel out, and you would have something that looked like 1 minus x squared plus x to the fourth minus x to the sixth. And since you know that based on the options there, n is always going to start from 1, so this would be the first term, second term, third term, fourth term, and we want it to alternate, so we would have a -1. We want the first term to be positive, so we would either have to do n minus 1 or n plus 1, but since the original example has n plus 1, that should be fine. So that would give us a positive term, and then we want to have, and it looks a little tricky there, but what we're going to get is x to the 2n minus 2. So 2 times 2 would be 4, 4 minus 2 would be 2. So for n equals 2, you would have an exponent of 2. Then when n is equal to 3, 2 times 3 is 6 minus 2 would give you the exponent of 4. When n is equal to 4, 2 times 4 would be 8, minus 2 would give you an exponent of 6. And so that appears to be it. There's nothing else in the denominator there. And from what I can tell, this appears to be option E. Now, a quicker way to do this might be to simply take the derivative of the general term itself. And when you're taking the derivative of the general term, you want to notice that everything stays the same. We treat -1 to the n plus 1 as a constant because there are no x's. There's no independent variable involved in that. Yes, the n's are changing, but remember, this is a function of x, not a function of n. And then we have x to the 2n minus 1, so we would bring the 2n minus 1 down, and then we would simply subtract 1 from 2n minus 1, and that would give us x to the 2n minus 2, and it would all be over what is there originally as 2n minus 1. From that, you can see that the 2n minus 1's cancel, and you end up with simply -1 to the n plus 1 times x to the 2n minus 2, which is what we had, with a lot less work. So the moral of the story is when you're trying to find the derivative, you don't need to write out terms and take the derivative of each term and then generalize again after that. You can simply take the derivative of the general term. Remember that anything that doesn't have an x in it will just be a constant, and that will stay the same in the derivative, sort of like the constant multiple rule for derivatives. And we'll simply do the power rule with the with any x factors that are in there. Alright, so hopefully that is clear. Both ways we came up with the same exact answer there. So we'll stop this video here.